All right, ready to dive into some C programming today.
Sounds good to me.
We're taking a look at a C programming lecture script, and it seems like it's all about how C handles data.
Yeah, it really is the heart of programming, isn't it?
Arrays, strings, structures, they're all here.
The foundations. And even though C's been around for a while.
It's like the classic rock of programming languages, right?
Yeah.
Still going strong.
Exactly. It's powerful, it's elegant, and so much is built on these core concepts.
Well, speaking of core concepts, the script jumps right into arrays.
Array.
It describes them as fixed-size collections of elements of the same type, which I get it, but maybe not everyone's got that memorized. What does that actually look like in action?
Okay, so think about it this way. Let's say you're keeping track of scores in a game you're building.
High scores.
Yeah, high scores. Instead of having a separate variable for each player's score, which would be a nightmare with a lot of players, right?
Oh yeah, chaos.
An array lets you store all those scores together under one name in a nice, organized way.
So it's all about keeping things tidy, making it easier to manage.
Exactly.
Now, the script also mentions that arrays are stored in contiguous memory locations. I always hear that term thrown around, contiguous memory. What's the big deal with C and contiguous memory when it comes to arrays?
It's all about speed and efficiency. When data is stored next to each other in memory.
Like houses on a street.
Perfect analogy. When they're all lined up like that, accessing and changing that data becomes super fast. No jumping around, no searching. It's one of the reasons C is known for its performance.
Makes sense. Direct access, no detours. Now, I know this is where things can get a little tricky, but the script mentions indexing starts at 0 in C. And this is one of those things that, I'll be honest, still trips me up sometimes.
It's definitely one of those C quirks that can take some getting used to.
Instead of thinking of it as the first element, you have to think of it as...
Element 0.
Right, like you're not counting things, you're... what, measuring distance or something?
Yeah, kind of. Imagine it like a ruler. You start at 0, and the first element is 0 units away. The second is 1 unit away, and so on.
Okay, I like that. It's a shift in perspective. So with arrays, you really have to stay within the lines. The script emphasizes the importance of staying within an array's boundaries. What happens if you wander outside those boundaries? Try to access something that's out of bounds.
Ooh, yeah, you don't want to do that.
Because C will let you?
It can. C's powerful, but it doesn't coddle you. Going out of bounds, it's like stepping off a cliff. You're trying to access memory that doesn't belong to your array.
Uncharted territory.
And it can lead to some pretty unpredictable stuff. Program crashes, weird behavior.
Best to stay on the trail.
Definitely stick to the defined paths.
Now, the script then starts talking about pointers. And this is where things always start to feel a bit abstract to me. Pointers. They're like...
the arrows pointing to the data.
Yeah. But how do they actually work with arrays? Because the script mentions that they're closely related.
They are. At their core, pointers are just variables that hold a memory address. Instead of storing the actual data, they store where to find the data. Think of it like a treasure map.
I like where this is going.
The pointer's not the treasure itself, but it tells you exactly where to dig. And with arrays, the name of the array actually acts as a pointer to the first element.
So it's like having the address of the first house on a street.
Exactly. And from there, you know how to get to all the other houses. That's where pointer arithmetic comes in.
Which the script touches on. But let's be honest, it's easy to get lost in the weeds with that one.
Pointer arithmetic can seem intimidating, but it's just a way to move between those memory addresses. By adding to or subtracting from a pointer, you're essentially hopping between different elements in the array.
Shortcuts.
Yeah.
Skipping houses.
Exactly. It's a powerful tool for working with arrays efficiently, especially when you're dealing with a ton of data.
Now, the script also mentions malloc and free, which always sound a bit technical. Where do they fit into all of this array manipulation?
These are your memory management buddies. Malloc and free are all about dynamic memory allocation. It means you can get more memory for your arrays while the program is running. You don't have to decide on the size beforehand.
It's like having an expandable backpack.
Yeah.
You can always make room for more stuff.
Precisely. Malloc is like asking for more space, and free is like giving it back when you're done. And trust me, you want to give it back.
Otherwise, you've got a memory leak.
Exactly. It's like leaving the faucet running. Eventually, you're going to have a problem.
Now, what happens when you want to pass an array to a function? Because the script mentions that you're not actually sending the whole array over, right?
Right. This is another one of those things where C is a bit different. You'd think you're handing over a whole box of stuff, but you're really just...
Giving them directions.
Yes. You're giving the function a pointer to that first element in the array. It's more efficient because it avoids making a whole copy of the array.
But it also seems like it could lead to some unintended consequences. If the function changes the array, it's changing the original. Right.
That's the thing with pointers, they're powerful but require caution. Any changes the function makes are happening to the actual array, not a copy. It's like sharing a Google Doc. Everyone's working on the same document.
So you really have to be mindful of what those functions are doing under the hood.
Absolutely. Clear communication is key.
Before we move on from arrays, the script drops a bit of a bombshell. It says you can't directly assign or compare arrays using those handy operators. Why not?
Yeah, that's a common gotcha for new C programmers. Remember how the name of an array acts like a pointer to the first element? Well, when you use or all with arrays, you're actually working with those memory addresses, not the data itself.
It's like comparing the street addresses of two houses instead of what's inside.
Precisely. To compare the actual contents of arrays, you'd need to go element by element.
So a bit more manual labor required.
Yeah.
Seems like C gives you a lot of power and flexibility, but it also expects you to know what you're doing.
Absolutely. You're in the driver's seat with C. It's not going to hold your hand, but it will take you wherever you want to go if you know how to steer.
Okay, let's talk strings. Now this is just a sequence of characters, right? Seems pretty straightforward.
You'd think so, right? But there's a bit of a twist in C. It's an array, yeah, an array of characters, but it's always got the special guest tagging along.
A special guest. You mean like a +1?
Kind of. It's called the null terminator.
The null terminator. I've seen it in code, that \0 thing, right? 0, 1.
That's the one.
What's its role in all of this? Why does a string need a null terminator?
Think of it like the end of a sentence. You need that period to know it's over.
Otherwise, it just keeps going and going.
Exactly. The null terminator tells the program, okay, this is where the string stops. Without it, things could get messy.
Functions would be lost, wandering around in memory.
Lost and confused.
So the null terminator is essential for keeping things organized.
It's a silent guardian, making sure strings behave as expected.
Love it. Now, the lecture script mentions a dedicated header file for working with strings, .string.h. What's the deal with that?
Think of header files like toolboxes. This one's got all the specialized functions you need for working with strings.
So instead of reinventing the wheel every time,
You've got pre-built tools ready to go.
nice. The script specifically calls out functions like stren, strapy, straycat, and straycamp. What are those all about? They sound a bit cryptic.
They're your string manipulation A-team. Strlen, that's your string length calculator, tells you how many characters are in a string.
Essential info.
Right. Then there's strapy. That one lets you duplicate a string.
Like a copy-paste, but for strings.
Exactly. Straycat is your string combiner. It lets you take two strings and merge them into one.
Handy for building up text, like file names or output messages.
Exactly. And finally, you've got storestramp, which compares two strings.
That one seems like it would come in handy a lot.
Oh, all the time. Checking passwords, sorting data, searching for text. It's everywhere.
Speaking of handy tools, the script mentions a common pitfall. Calling Stroslen repeatedly within a loop. Why is that a no-no?
It's all about efficiency. Imagine measuring the length of a rope every 5 seconds, even though you know it hasn't changed.
Seems like a waste of time and energy.
Exactly. Calling Strlen inside a loop, when the string's length isn't changing, that's a recipe for slowing things down. It's much better to calculate it once at the beginning and store that value.
Work smarter, not harder.
Absolutely. Now, ready to move from the world of strings to something even more powerful.
Hit me with it. What's next?
Structures. We're talking about grouping different kinds of data together in a meaningful way.
Okay, I'm intrigued. The script describes structures as a way to create your own custom data types. Why is that so beneficial?
Well, imagine you're building a program to manage, say, a library catalog.
Lots of books, different authors, publication date.
Exactly. You've got all this information about each book title, author, genre, publication year. Trying to represent all of that using just arrays of numbers and characters would be a nightmare.
A recipe for a major headache.
Right. Structures let you encapsulate all of that related data into a neat little package. You could define a structure called, say, book, and it would hold all those pieces of information together.
Like a digital library card for each book.
Perfect analogy. It makes your code so much more organized and readable.
And the script mentions using the dot operator to access members of a structure. That seems pretty straightforward, just like accessing elements in an array, right?
It is. But here's where things get a little more interesting. What if you have a pointer to a structure? Like if you allocated it dynamically using malloc.
Ah, pointers.
They always seem to find their way back in.
They're the glue that holds so much of C together. So when you have a pointer to a structure, you use a different operator, the arrow operator,
Yeah.
to access those members.
It's like a special pointer tool, right, for those indirect accesses.
Exactly. It highlights that pointers and structures often go hand in hand. And that brings us to another important concept that the script touches on: shallow copying.
Shallow copy. Now, that sounds a bit ominous. What's that all about?
It's a common source of confusion, especially when you're working with structures that contain arrays or other pointers. You see, when you make a copy of a structure, you might think you're getting a completely independent duplicate.
Fresh start, no strings attached.
Not quite. If a structure member is a pointer, like an array, you're only copying the pointer itself, not the data it points to.
So it's like having two different remotes that both control the same TV.
Perfect way to put it. They might look different, but under the hood, they're both connected to the same thing. Change the channel on one remote, the other reflects that change too.
That could lead to some unexpected results if you're not careful.
Exactly. That's why understanding deep copying is crucial. With deep copying, you'd create a truly independent copy, including the data that those pointers are referencing.
So two TVs, two separate remotes, no accidental channel changes.
Exactly. Now, one thing that often trips up new C programmers: can we compare structures directly using the equality operator, that double equals sign?
I would assume so. But with C, you never know. What's the verdict?
Unfortunately, no. Direct comparisons with structures aren't allowed in C. It's because structures often have multiple members, potentially of different types, and comparing them all at once would be...
Too much for C to handle.
It's more that it would be ambiguous. It could lead to confusion about what's actually being compared. So if you need to check for equality between two structures, you'll need to compare each member individually.
Back to the drawing board. Or rather, back to comparing each element one by one. It seems like a common thread with C. It gives you immense power and flexibility, but it also requires you to be very explicit about how you want things done.
Exactly. You have fine-grained control, but that means you have to be precise. Now, the script wraps up this section on structures with a really interesting coding challenge. Ready to put your knowledge to the test.
Always up for a challenge. What's the task? Lay it on me. What kind of challenge are we talking about?
So it starts with defining a structure, right? Like we were talking about.
Okay.
But this one's going to represent a point in 2D space, like on a graph.
So it'll have an X coordinate and a Y coordinate.
Exactly. You got it.
Mhm.
Now, the challenge is you've got to create an array of these points.
Okay, so multiple points.
A whole bunch of them. And then write a function that can take that array and find the centroid of all those points.
Find the centroid. Now that's taking me back to geometry class. For those of us who might need a refresher, what is a centroid again?
Basically, imagine you sprinkled a bunch of dots on a piece of paper, right? The centroid is like the balancing point. If you could balance that paper on the tip of your finger, the centroid is where it would be perfectly balanced.
Ah, the center of mass.
Exactly. It's a pretty useful concept in all sorts of programming, too. Computer graphics, image processing, even mapping and data analysis.
So this challenge, it's about taking all those individual point structures and finding that balancing point for the whole group.
You got it. It's a really practical way to see how structures, arrays, and a little bit of math all come together in C.
Very cool. Man, this deep dive into C has been quite a journey. We've covered so much ground, from those basic building blocks of arrays and strings to the more complex world of structures and pointers.
And we even threw in a little geometry for good measure.
Exactly. But you're right, we've really only just scratched the surface of what C can do.
C's got so much depth. It's amazing how these core concepts we've talked about, though, they really are the foundation for so much more you can do with the language.
It's like learning your scales on the piano.
Exactly. You got to master those fundamentals.
Before we wrap up, what's one thing about C that really stands out to you, especially given that it's been around for so long and is still so widely used?
For me, it's C's elegance and its power, the way it combines simplicity with this incredible control over the hardware. It's just remarkable, and it's no wonder it's still so relevant today, especially when you think about things like embedded systems, operating systems. Any performance is super important.
It's a great reminder that the classics never really go out of style, do they?
Nope. And with technology changing so fast, learning C, understanding those core principles, it's a fantastic investment for any programmer.
It's been awesome exploring the intricacies of C with you today. Any parting words of wisdom for our listeners who might be feeling inspired to fire up their code editors and start experimenting with everything we've talked about?
Just one. Don't be afraid to break things.
Wait, really? Break things?
In a controlled way, of course. Experiment, try new things, and yeah, you might run into some errors, hit a few roadblocks.
That's part of the learning process.
Exactly. Embrace those challenges, figure out how to solve them, and I guarantee you'll come out the other side a much stronger C programmer.
Couldn't have said it better myself. Well, on that note of embracing the challenge and always staying curious, it's time for us to wrap up this deep dive. Thanks for joining us, everyone, and until next time, happy coding.
See you next time.